Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review equations. So equations are just expressions with an equal sign and we solve equations. What that means is in each of these equations, I want to find a number that I can substitute for the pronumeral or letter, in this case x, in order that I make each of these a true statement. So let's start by solving this one here. So I put this one here on purpose because equations like this seem to cause people problems. They're not exactly sure what's happened. See, that's the first thing we need to do. We need to identify what's happened to the pronumeral, in this case x. What operations have been performed? We then need to undo those. So this 38 here is a positive. So the only way we could get that 38 there is if it was added. So that's positive 38. And the coefficient of x is not 5, it's negative 5. See what has happened here? X has been multiplied by negative 5, then 38 has been added to give 73. And I know that it was done in that order because of BIDMAS, but when I'm solving, when I'm undoing the operations done to x, I need to go in the opposite order to BIDMAS. So it's just like in the morning, you put on your socks first, then your shoes. At night, you have to take off your shoes first because they were the last thing you put on. Similarly here, plus 38 is the last thing put on. I know that because of BIDMAS. So when I'm solving, it's the first thing I undo. You undo adding 38 by subtracting 38, because plus 38 minus 38, they cancel out. You're just left with 0. So when you're solving equations, the golden rule is what you do to one side of the equation, you must do to the other. If I subtract 38 from the left-hand side of the equal sign, I must also subtract 38 from the right-hand side of the equal sign. So what I'm going to be left with is minus 5x equals, now 73 minus 38 is 35. So again, this is a negative 5, not a 5 in front of x. So the way you undo timesing by negative 5 is to divide by negative 5. Again, what you do to one side, you must do to the other. So timesing negative 5, divide negative 5, cancel each other out. I'm left with x equals 35 divided negative 5 is negative 7. So this is the solution. What it means for it to be a solution means this is the value that if I substitute for x, I get a true statement. You can easily check whether it's the solution and check if you're right by taking your original equation, 38 minus 5x equals 73, and substituting or exchanging x for the value found at negative 7. This is a true statement because 38 plus 35 does equal 73. So linear equations like this, they almost always have one unique solution, one and only one solution. Very rarely they'll have 0 or infinitely many solutions. Almost always they have just one solution, and we found it. All right, let's look at this one here. So again, we need to identify what's been done to x. So starting with x, the first thing that was done was negative 2. So 2 was subtracted from x. Then we divided 5. Now then there's a minus in front of here. That's the same as timesing by negative 1. And then this 4, similar to the last example, is a positive 4. So we have subtracted 2, divided by 5, times by negative 1, then added 4. So because adding 4 is the last thing done to x, it'll be the first thing we undo. We're going to subtract 4 from both sides because adding 4, subtracting 4 cancel each other out. So I've still got that negative there. Negative x minus 2 on 5 equals 1 minus 4, which is negative 3. Now, you can do whatever you want to one side of the equation as long as you do it to the other. So I can change this to a positive. I can change the sign of the left-hand side as long as I change the sign of the right-hand side. So now I've got x minus 2 over 5 equals 3. We undo dividing 5 by multiplying by 5. Again, what you do to one side of the equation, you must do to the other. Divide 5 times 5 cancel out. So I've got x minus 2 equals 3 times 5 is 15, and then you undo subtracting 2 by adding 2. Once again, what you do to one side, you must do to the other. My final solution here is 17. This is the solution because if I substitute x for 17, I'll get a true statement. 17 minus 2 is 15. 15 divided by 5 is 3. 4 minus 3 is 1. If I substitute x for 17, I get a true statement. All right, let's now look at some harder examples. So what makes each of these examples harder is that x is in more than one spot. We really only know how to solve equations. We can really only use the steps in the previous slide when x is in one spot. So if you have an example where you have x or any pro-numeral in more than one spot, first get it to one spot. So let's look at this one. Let's get x to one spot. The only way I'm going to be able to do that is expand the brackets. So I'm going to leave the 5x alone. Now this negative out the front is the same as if it was a -1 out the front. Just mathematicians are lazy and don't always write things if they don't need to be written. So we have -1 times 4 using the distributive law. Now -1 times negative x is positive x. So now we can collect like terms. 5x plus x is 6x. You can't add or subtract 6x and 4. They're not like terms. So now we have an easy equation to solve. We simply add 4 to both sides and then divide each side by 6. Once again, once we've got x to only one spot, as we did here, we just undo what's been done to it in the opposite order to BIDMAS. So x equals 9 is the solution, because if you substitute x here and here for 9, you get 45, subtract -5 equals 50, which is a true statement. All right, let's look at this one. So this one's a bit harder. We need to get x to one spot. So what we want to do is we want to get rid first of these fractions. So what I can do is I can multiply each side by 6 to get rid of this 6 here, because times 6 and divide 6 undo each other. The thing is, if you're multiplying this side by 6, you have to multiply the whole shebang by 6. So you actually have to multiply this one by 6. Now note, when you're multiplying a fraction by a whole number, you only multiply the top. You don't multiply the top and bottom by 6. That would be equivalent to multiplying by 1. We're not looking for equivalent fractions here. We're just multiplying this by 6. So what I'm going to end up with is x minus 3, subtract 6 outside of 1 minus x. I've still got the 7 there, and then 4 times 6 is 24. So now I'm going to get rid of this fraction by multiplying by 7. So once again, if I multiply this side by 7, I need to multiply the whole shebang. I need to multiply that by 7, and I also need to multiply this fraction by 7. So I get 7 outside of x minus 3. Now when I multiply this fraction by 7, the denominator just goes away. So I'm left with minus 6 outside of 1 minus x. And of course, what you do to one side, you must do to the other. So I'm going to times 24 by 7. So I still have x in more than one spot. I've got to get it to one spot, and I'll do that by expanding the brackets. So I go 7x minus 21 minus 6 times 1. Negative 6 times negative x is positive 6x. So let's collect like terms. 7x plus 6x is 13x. Negative 21 minus 6 is negative 27. So now I have reduced this to an easy equation to solve where x is in one spot. I'm simply going to add 27 to both sides and then divide by 13. So I get x is equal to 15. That's the solution. If I substitute x for 15 here and here, you can easily check I get a true statement. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.